Hello everyone, my name is Mathew Marcellino and my student ID number is 210-553-1065. My major is in mechanical engineering and today we're going to continue our study on machining processes. So in this presentation, I'm gathering other resources from this handbook of manufacturing processes, how products, components, and materials are made by James Gabriela, and then some from the article in Google and also some YouTube videos. And today we're going to discuss about chapter 3, which is machining processes. The contents in today's presentation, there's 3 subjects. The number 1 is D, milling, and then E, skew threads, and then F, broaching. Alright, let's get to the subject D, which is milling. Okay, milling is the process of machining using rotary cutters to remove materials by advancing a cutter into a workpiece. This may be done by varying direction on one or several axes, cutter head speed, and pressure. As you can see in this animation, there are several axes for cutter head speed and also pressure to make the milling processes happens. Alright, next, which is D1, is face milling. Face milling produces a flat surface at a right angle to the axis of rotation of the cutter. Depending on the depth of cut, some machining also takes place on the periphery of the cutters. Okay, next, which is D2, peripheral milling. Peripheral milling is a machining process in which the milling cutter is placed parallel to the workpiece. In other words, the milling cutter is positioned so that the sides of the cutter grind away at the top of the workpiece. Okay, the next one, which is D3, end milling. An end mill is a type of milling cutter, a cutting tool used in industrial milling applications. It is distinguished from the drill bit in its application, geometry, and manufacture. While a drill bit can only cut in the axial direction, most milling bits can cut in the radial direction. So, as you can see, the mill drilling bit is different from a normal drill bit. Wow! Normal drill bits can go in axial direction, but milling bits can go radial direction. Okay, we are going to go next, which is D4, which is slab milling. Slab milling is peripheral milling with cutters that produce a flat surface over a wide area. The axis of rotation of the cutter is parallel to the machined surface. The cutter often removes a large amount of materials. So, as you can see, this is the cutters, this is the workpiece. They cut away the workpiece, making it a flat surface. And they can also drill the workpiece. In here, as you can see, they are making the flat surface on the side, and for the other operation, they're making a little bit hole inside the workpiece. It's not like a hole, but it's like a slab. Alright, the next one, which is D5, form milling. Form milling is a type of CNC operation which is ideal for shaping irregular contours, including curves and sometimes straight lines. All this done in a single cut using form milling cutters. So as you can see, this is the form milling cutters. They have like a form, like a milling, and they make the form while doing the operation in one single operation. Okay, this is an example of a video of a form milling. As you can see, this is the workpiece, the darker spot, and this is the milling, which has the pattern to make a form, and they are doing it in a single operation, just like that. Single operation forming the workpiece as in the video. Okay, the next one, which is D6, gang milling. Gang milling is simply milling with more than one cutter on the arbor of the milling machine. This produces a multiple surface on the workpiece with one pass of the cutters. So as you can see with this image, this milling cutter, they have more than one milling cutter, and they make the operation to the workpiece in one pass, and they form the workpiece as intended. Okay, next, D7, straddle milling. Straddle milling involves the use of two cutters on one arbor with a space between them. Two surfaces are cut in one pass, but the area between them is not machined. So this is an example of gang milling, but it's only using two cutters, and they cut in one pass on the side, and they leave the middle one just by itself. They don't machine the middle of itself. Okay, here we can see an example of straddle milling. They cut the side, but they don't cut the middle workpiece. Okay, next, D8, fly cutter milling. Fly cutter milling involves the use of a single point cutter rather than a multiple tooth cutter to perform a milling operation. It is face milling with only one cutter tool. The method is useful for producing flat surface in a tool room situation where the optimum multiple-toothed cutter may not be available. So this is just a options if you want to make a flat surface, while the main operation is not available. Alright, next one, D10, spot facing. A spot face or spot face is a machine feature in which a certain region of the workpiece is faced. providing a smooth, flat, accurately located surface. Here's some example of a video of spot facing. Here you can see there's a hole, and the spot face is going to make a flat surface on the hole, just like that. Okay, let's get to the next subject, which is E, screw threads. Screw threads are made with a large number of different methods involving both machining and forming processes. Cutting methods include the use of hand-operated tabs and dies for internal and external threading, and machines for single-point screw thread cutting die heads, thread milling, and thread grinding. Alright, let's get to the E1, which is hand die external threading. These are called button or cone dies and are useful for cutting screw threads in prototype and limited quantity production. The die is placed on the end of the screw blank and is rotated with a wrench-like tool. It fits itself forward the lead thread of the screw as it cuts the thread. So the hand die external threading uses a hand to make the thread happen. So this is for example this is a thread, and usually there's like a handle that we can use to make the hole and the thread like this. This is for the example of the finished products. Alright, next E2, internal thread tapping. Utilize tabs. The tab is rotated like a drill or reamer and is self-fit actually into the hole in the workpiece to create an internal thread. Tabs can be positioned and fed manually and rotated with a hand tool, or can be used with a drill press, lathe, automatic screw machine with a tapping attachment, or a special tapping machine. Here we can see an example of video internal thread tapping. So the thread are placed with a machine, precise machine, and it's going to make a thread on the internal of the workpiece. So that's the finished product. They make a huge thread inside the workpiece. Okay, the next one, which is E3, single point screw thread cutting. It is a lathe operation, a form cutting tool that has a profile corresponding to that of the space of or spaces between the required screw thread. Makes repeated passes along the workpiece. The cutter is attached to the lathe carriage and it is moved longitudinally along the bed by the lathe's lead screw, which is geared to provide the rotational thread needed to produce a screw of the proper pitch. Okay, the next one, E4, thread cutting die heads. Are efficient, accurate, and widely used in production threading. They are used on all kinds of lathes and screw machines, on drill presses, and as part of special threading machines. They have sets of insertable multiple tooth cutters that are changeable when different pitches of thread are to be machined or when the cutters need resharpening. Next one, E5, thread milling. Utilize a form milling cutter. Both the workpiece and cutter rotate. Most cutters are the multiple rib, but single rib cutters are also used through cutting one. The method is applicable to both internal and external threads. As you can see in the image here, this is multiple rib and this is single rib. Next one, E6, thread grinding. It is used when particular accuracy and surface smoothness are required. Threads are ground in stainless and tool steels and in sintered iron components, particularly when they have been heat treated for hardness or are used in precision applications such as adjustment screw and fit screws. As you can see in this method, there are the grinding machine to make the screw thread are smooth. Next, E7, thread rolling is a cold forming method for making external screw threads. Thread rolling is a metal forging process that forms threads into the mirror image of a roller drive. The process is different from metal cutting, grinding, and casing because it does not remove any metal from the workpiece. Here are some examples of the video of thread rolling. So they make the thread as the video. They mirror the thread and make it does like that. Okay. Alright, let's get to the next subject, which is F, broaching. Broaching is a high production machining operation that involves the one-way movement of a broach, a cutting tool with a series or of progressively stacked teeth. The teeth move parallel to the surface being machined, and each one removes a precise amount of material. The action is similar to that of a saw, except that each tooth is set slightly higher than the one that precedes it and is wide enough to machine the entire surface. Next one, the F number 1, which is internal broaching, is machining by broaching the inside surface of a hole or other opening in the workpiece. The most common broaching operations produce keyways, key slot opening in locks, spline shaped openings, and other non-round enlargement of holes in pulleys, gears, or other parts that are to be fastened to shafts. Alright, next one, F2, external broaching. It's similar like internal broaching, but the broaching here, it occurs in the external of the workpiece. It takes place when the broaching tool machines an outside surface of a workpiece. These are the examples that are machining of flat surface, cam surface, and gear or ratchet tip. So as you can see, this is the example of the finished product of external broaching. Okay, the next one, which is F3, hot broaching. It uses a ring or tubular shaped broaching tool with the cutting teeth on the inside. Normally, the workpiece is pushed through the tool with hydraulic force. The tool cuts the entire workpiece periphery in one pass, which is super cool. That there's a broaching that makes an inside shape like this in one pass. Okay everyone, I think that covers the entire presentation today. I hope you learned something in this presentation, and if I have some mistakes or maybe wrongdoing, you can let me know, and I wish you have a good day. Thank you, bye bye.